Hi, my name's John Merchant, and I'm going to replicate a presentation that I've made recently at a couple of events, primarily the Building Smart International Summit in Paris, but also the Melbourne BIM Music Group Melbourne. The presentation's object libraries, why aren't they common? And when I say common, I mean why aren't they shared and used across the majority of our industry rather than a lot of individual companies having to duplicate and replicate a lot of the same effort across the industry. Why they aren't common is reasonably easy to identify. What this is costing our industry, I don't know, but the fact there is a lot of replication and duplication means there's a lot of gains to be made out of common object definitions. How we address this and make them common is also probably where the challenge is, and I certainly don't have all the answers on that. Some quick background to me, that those that don't know me, I worked as a structural engineer for about 10 years, having completed studies in structural engineering and computer science. For the last 8 or 9 years, I've primarily been developing software in the form of plugins to help facilitate interoperability between a lot of different applications used in the architecture, engineering and construction industry. IFC, or Industry Foundation classes, which I'll explain a little bit more in a second, have been key to enabling that interoperability. Object libraries aren't commonly provided out of the box by the typical authoring application developers. They do take a lot of time and effort to develop, therefore they have value, and that discourages sharing the effort that you've had to invest with your competitors if it's back down to the end users to prepare this content. And because object libraries to date have been manually generated, maintenance and updating, coordinating provides many challenges through past and existing projects. Companies have individual standards and requirements relating to particularly naming conventions of properties and parameters, also the appearance of line styles and hatching, the version of the authoring application required, etc., presents challenges. There's been no typical adoption of a standard object library definition, although I've seen a lot more effort to try and consolidate this, and hopefully that is beneficial, even if content remains manually developed. A lot of content is poorly developed, so downloading content from the internet presents risks and other issues downstream, meaning that a lot of users have been preferred to invest a lot of that time and effort into content they trust. End users have very little influence on improving generation content process, and proprietary authoring implementations can often hamper the process of distributing some of this content. As an industry or even as a region, it's pretty unlikely we'll ever agree to naming conventions. So the ability for end users to configure this as the content is created can help encourage adoption and use of this. And companies and projects will have different requirements, such as aspects such as hosted or freestanding equipment behavior. So what I would suggest is that maybe we overhaul the content creation process from, instead of it being occurring and then downloading the end result, is to facilitate the definition of the common objects, and then have the authoring applications create this from effectively the instructions or recipes that define these objects. And this would then, because the object content libraries are actually created on the fly at their desktop, they could allow the end users to control and configure the object creation with some of those inputs, such as naming conventions and templates and other company or project requirements. I was supporting a object library project in the Netherlands a couple of years ago, which is effectively what I'm going to demonstrate in a second. And there was a proof of concept that we did in terms of collating a database of object definitions. They were stored reference to a standard such as ETIM, defining what the dimensions are and the attributes or the performance of the objects in question. And where I particularly got involved with was then, well, how do you convert from a database into a model authoring software such as Revit? And there is an emphasis on Revit in this presentation, but certainly other authoring applications are involved in reviewing this, and this presentation or work has been discussed with other authoring software applications subsequently. The intention is that the object definition is not just for design and authoring, but for fabrication, procurement, installation, and then operations and management, etc. Downstream from there. So particularly then, in this case, we got invested and tested and researched how we could use IFC or industry foundation classes to define this object library. Because the back end was all done in JavaScript, they particularly wanted to format the data model in a JSON expression, but this same proof of concept works with Step or XML. And particularly the role that I helped undertake was then how to define the object from a database into an IFC object library, including intelligence. So often object library or manufacturers can provide content in, say, a proprietary format and then an IFC format, although typically then that's been a coordination static object, whereas what we wanted to demonstrate is that you could, or I'll show in a second, is how you can create parametric content. And so my role was particularly then, or the tools that I've been developing, is how do you take an IFC intelligent definition and convert that into an intelligent proprietary object definition such as RFA, and then as part of that process allow the user to configure some of the inputs such as naming or shared parameters and template or some of these other sorts of inputs. The proof of concept was primarily mechanical and services equipment. And we did about 7 or 8 different objects such as air terminals, pumps, light fittings, heaters, and that type of thing, showing that there was or testing a few characteristics and attributes of this during the process. So the proof of concept work there actually was a web front end to this, which could be loaded in a Revit plugin that would allow a user to browse through the database to filter out the role of the equipment they needed, such as the air terminal, to set configuration such as the language, and to search or filter based on characteristics or requirements that might be needed on that equipment. That website's no longer live, so I'm just going to effectively assume I've gone to that website, selected the air terminal that I desire, and then that air terminal has been downloaded onto my computer as an IFC file. For this particular demonstration, I'm just going to click on my Import IFC button, pick that IFC file, and then what you'll see is that the plugin is opening a Revit template, building effectively from that instruction set the Revit family content, and then loading that into the project so that now exists as a piece of equipment that I can then start populating and using here in the project. So I'm going to place a couple of instances of this air terminal object, and part of this was showing that it's not just dumb static object. IFC does have different geometric representation contexts such as 3D model view or annotations. So if I start changing some of the annotation parameters which existed as IFC properties in the IFC definition, the concepts are very similar in IFC and Revit in all of these sort of things I'm demonstrating here. You'll see is that the annotation representation of this object gets updated on that on the changing of those inputs here on these objects. There's also some length constraints and things like that applied where I can flex and change the content. As part of this, the IFC has a similar concept that Revit does for systems and ports and connecting air terminals to ducts or other equipment to piping, etc. So there is a connector port here from a distribution port in IFC, and then I can actually change the diameter of that connector port and have that update and flex as part of this object. If I quickly showed you the family object that created, is that then you would see that some of the constraints are applied here, and IFC even can have the equivalent to a calculated value in the Revit content, so it can do at least reasonably, or it can do basic arithmetic operations such as multiplication, division, subtraction, etc., which then can correlate into the function or formula definition of that calculated value in Revit. So I'm certainly at least not proposing that IFC is perfect for common object libraries, but it's is capable of a decent level of sophistication, and we can improve it. But the first thing to improve it is to identify what it's already capable of and test and provoke that. So if anyone has questions or comments, then please feel free to contact me on the contact details shown on this slide. I'd certainly look forward to hearing feedback and suggestions on this work.